Alright, so let's continue from where we stopped in our revision session. So we have so far discussed about transaction, its operations, its state diagram, the atomicity, the consistency, the isolation, the durability, the serialized schedules, the interlude schedules, serializability, view conflict and view serializability. Then we have seen two-phase commit protocol. Then we have seen log-based recovery and checkpoints-based recovery. So I hope there is no doubt till now. Everyone? Any doubts? Anyone till now? Yes, anyone is having any doubts? Anyone? Any doubts till now? Yes or no? Yes or no? Okay, then let's continue. The next topic is shadow paging. Now the third way of recovering a database, right, is shadow paging. Now what is shadow paging? We can assume that each of our database will be divided into some different pages, and mainly the database or the transaction manager will have two different page tables, and each pages will be stored in this page tables. So one is current page table and second one is shadow page table, and we have one more page table known as new page table. So initially whenever the transaction starts, right, the current page table and shadow page table will point to the same database or same pages in which the data is stored. Now whenever there are some changes being made by the transaction, then the current database or the current page table will start pointing to the new data, and the shadow page table will still keep pointing to the same page table, the old page table. So whenever there is some error, we can use this shadow page table and get the status of the database. We are not going to look over to the current page table. You can see this particular diagram. You can see current page table and shadow page table are pointing to page 1, 2, 3, 4, 5 in new page table. This is the initial stage. Now after some time, the transaction has made some changes in page 2 and page 5. You can clearly see here. So now the current page table is pointing to the new values, as well as at the same time the shadow page table is pointing to the old values. So this shadow page table can be used to get the status or get the old database in case of failure in the transaction, because we want to revert back all the changes being made to the database by the transaction, but now the transaction has got failed, so we will use this shadow page table. So these are the mainly three ways of database recovery. There is one more way of database recovery, but that is not that much useful. But shadow page table or shadow paging is the most effective database recovery component, or I would say database recovery module, right? So the next one I can say for database recovery is cascading rollback. Now what is cascading rollback? Let's say we are having three different transactions. T1 is working on data item A, T2 is also working on data item A, and T3 is also working on data item A. So now what is cascading rollback? Let's assume that T1 has made some changes in data item A that is being read or used by transaction T2, and T2 has also made some changes to data item A that is being read by transaction T3. It is being also used by transaction T3. Now assume that after some time T1 failed. After some time T1 got failed. So we already know that T1 or T2 was dependent on data of T1 and T3 was dependent on data of T2. So ultimately T3 was also somehow dependent on T1, right? So if T1 gets fail or there is some error and it is being rolled back, then ultimately and automatically T2 and T3 also should be rolled back. That is what cascading rollback means. If some transaction is dependent on the value of some other transaction and that other transaction gets fail, then the all the depending transactions will be also getting failed. So this is what the concept of cascading rollback means. This is what this is what the concept of cascading rollback means. Clear with this, guys? What is cascading rollback? Or any doubts? Then we can start with the new topic called concurrency control. Yeah, any doubts? Anyone? Yes, any doubts? Anyone in this so far? Anyone? Any doubts so far in this? Yes or no, guys? Okay, then moving on next, we are talking about concurrency control. Now, what do you mean by concurrency control? Concurrency control means we are allowing more than one transactions to execute their operations on the same data item at the same time. That is what concurrency control means, right? Two or more than one or more than one transactions rather, right? More than one transactions working on same data item at the same time. That is what concurrency control means. So we need to manage all these things, that we are going to allow more than one transactions to execute their operations on same data item at the same time. So how to manage this? So to manage all these things, we also need to manage the conflicts. If there is a read and write operations for two different transactions at the same time, we need to manage this type of conflicts also. So what we will do in this case, we are going to work on lock based protocol. We are going to work on lock based protocol. Now what is locks? Locks means similar to the operations we are having similar to the operations we are having two types of locks. So locks means a transaction can acquire a locks for their operations. There can be a shared lock and there can be a exclusive lock. Now what is shared lock? Shared lock means a transaction is having rights to only access or see or look over the data. That is what we call it as shared lock. Right? And what is exclusive lock? A transaction is having rights to do anything with the database. That means you can add some data, you can modify some data, you can delete some data. Whatever things a transaction wishes to do, that a transaction is allowed. Right? So this is what exclusive lock and shared lock means. Right? Exclusive means anything can be done on the database. Shared lock means only read operation, access of the data. So let us say if one transaction is having shared lock and also the other transaction also wants the shared lock, yes, that can be allowed. But one transaction is having exclusive lock and the other transaction wants shared lock, then it is not allowed. Let us say one transaction is having exclusive lock and other transaction also wants the exclusive lock. It is also not possible. So only two transactions can have shared lock, that means read permissions on the same data item at the same time. They cannot have conflicting operations or conflicting locks at the same time. Clear with this concept, guys? So this is what we are going to look over in this concurrency control, a lock based mechanism. So let's see lock based protocol. So what we are saying, each transaction whenever they want to perform their operations, they will request the lock manager to assign a particular type of lock. They will request that I want shared lock or I want exclusive lock. Depending on the request and depending on the availability of the locks, then the lock manager will grant the permission, will grant the lock to the transaction. Once the grant has been received by the transaction, then and then the transaction will start performing its own operations, and then once all the operations of the transactions are done, right, at that time the transaction will release the lock acquired. That means if the transaction has acquired exclusive lock, then after all its operations are done, the transaction will release all its acquired exclusive lock. They will have to release so that other transaction can acquire it or can get it. Right? So this is what we call it as lock based protocol. So let's see here. We are having two-phase locking protocol or lock based protocol. We are having two parts, growing phase and shrinking phase. What is growing phase? In growing phase, the transactions can only request for the locks, right? And in shrinking phase, the transaction can only release the locks. These are the two main concepts of two-phase lock protocol. In growing phase, transactions request and get the locks, and in shrinking phase, transactions release all the acquired locks. That is what the two-phase lock protocol says. So how it works? Let's say one transaction T1 wants exclusive lock. So it will request lock manager to give him exclusive lock on data item A. So that is what growing phase means. In growing phase, a transaction cannot release any locks. Only it can request for acquiring the locks, to get the locks, right? So transaction T1 requests to get exclusive lock on data item A. So lock manager gives the permission to get the lock and gives him that lock. So now growing phase is done, and now transaction is going to execute all its operations. After the operations are completed and commit command is executed, then transaction will release all the locks, that is exclusive lock. So T1 is now going to release the exclusive lock and will intimate the lock manager that I have released the exclusive lock on data item A. So that is what shrinking phase is. In shrinking phase, a transaction cannot get any type of locks. Even after the growing phase and before the shrinking phase, that is between growing and shrinking phase, when the transaction is actually executing all its operations, it cannot get any type of locks. Whatever locks that transaction requires, it has to get in growing phase before the transaction starts its execution. So this is what two-phase lock protocol means. Any doubts, anyone, in this two-phase lock protocol? Anyone, Any doubts in two-phase lock protocol? Alright, if there is no doubt, let's move ahead. For two-phase lock protocol, we are having two types. Rigorous strict two-phase locking protocol and rigorous two-phase locking protocol. Now what is strict locking two-phase locking protocol? Let's say transaction T1 has got or requested and also got shared lock on data item A, shared lock on data item B, and exclusive lock on data item C. Now after this growing phase, it has performed all its operations, and before the syncing phase, a transaction can release all the shared locks. Right? Before the commit command, the transaction can release shared lock. That is what strict two-phase locking protocol means. That means T1 can release shared lock on data item A and data item B, but it cannot release exclusive lock on data item C until and unless the transaction has given commit command. So that is what strict two-phase commit protocol means. Exclusive lock cannot be released before the commit command. Shared lock can be released by the transactions before the commit command in the syncing phase. Next is rigorous two-phase locking protocol. Now what is rigorous two-phase locking? It clearly says that the locks that has been acquired by the transactions, none of the locks can be released by the transaction until and unless the commit command has been executed. Even the shared lock cannot be released. Even the shared lock cannot be released. Right? So that is what rigorous means. No locks can be released before transaction gives commit command. And in strict, you can still release shared locks in strict two-phase locking. So these are the two types of lock-based protocols or two-phase locking protocol. Just go through this slide, and if you have any doubts, just tell me. Just go through it, and if you have any doubts, just tell me. Yeah. Strict two-phase locking and rigorous two-phase locking. Anyone? Any doubts till now? Anyone? Any doubts till now? Yes or no? Anyone? Any doubts so far? Okay, then let's move ahead. The next topic is about what can be the problems with the concurrency control. If we are not able to manage the concurrency control, or we are not able to manage the concurrent transactions in an efficient way, then what could be the problems? The first one is deadlock. First one is deadlock. You can see the example clearly. T3 has got exclusive lock on B. It is performing all its operations. That is okay. T4 has got shared lock on A. It is performing the operations. Now T4 wants shared lock on B. But here you can clearly see that T3 has not released that lock. It has not released that particular lock on B. And at the same time also T3 is also willing to have exclusive lock on A, and that is also being not released by T4. So you can clearly see here neither T3 nor T4 can move ahead in their transactions because both of them are waiting for each other to release their individual locks. So such type of condition we call it as deadlock. Such type of condition is known as deadlock, where one transaction is waiting for some other transaction to release their resources, right? So if we want to solve this particular problem, what could be the solution? Only one solution is there. We have to roll back one of the transaction. That is either T3 or T4 will be rolled back and all its locks will be released. Right? This is the only solution for this type of scenario. And the second condition or second problem that we can face in this particular concurrency control is starvation. Now what is starvation? Let us assume that there is one data item A and transaction T1 is willing to have exclusive lock on data item A, but it has been asked to wait by the lock manager that we are not able to give you this exclusive lock on data item A. What is the reason for this? The reason is there are some different transactions from T2 to T10. They are requesting shared locks on data item A, and the lock manager is giving them the permission to get the lock, and all the transactions from T2 to T10 are getting those locks. They are performing their task and they are releasing their locks. So what happens in this case? T1 is being asked to wait and wait and wait while other transactions are requesting for the locks and getting the locks on the same data item. So this is what the condition we call it as starvation. Starvation means one will be kept in the infinite waiting stage while others will be getting the resources quite smoothly. Right? So that is what this starvation means. Here transaction T1 has been kept in the waiting stage while from transaction T2 to T10 all of them are getting their resources and they are performing their operations. So there can be two problems if we are not able to manage our concurrency in an efficient way. One is deadlock and the second one is starvation. Deadlock means one operation is waiting for some other operation to release the resource, and starvation means one operation has been kept in the waiting stage and while the other transactions are able to perform their operations on the same data item. So this is what the concept of deadlock and starvation means. Anyone? Any doubts? Yeah, you can go through the two slides, deadlock and starvation, and if you have any doubts, kindly raise it. Yeah, the deadlocks and the starvation. Any doubts? Anyone? No doubts, guys? Okay, then let's move ahead. And this is what I said. We have some other types of locks also. We call it as intention shared and intention exclusive, and shared and intention exclusive. But that means that we are intentionally forcing that particular database, or we are forcefully taking or getting the locks on some other data item. Other than the shared lock, we are also forcefully, intentionally getting the locks on some other data item. Let's say where this is used. This is used where you have tree-like structure and you have stored your data in this particular format, that is tree-like structure. There will be one root. The root will have child. Child will have subchild. Subchild will have more subchilds. Likewise, you will have such type of storage structure. So let us assume that transaction T1 has got a shared lock on file 2. A transaction T1 has got shared lock on this file 2. So now, because it is a tree like structure, we have to use intention shared lock also. That means all its child. What are the child of file 2? Page 1, page 2, page 3, record 1, record 2, field 1 and field 2. So all the child of the file 2 will be intentionally locked by that transaction T1, because we don't want that some other transaction access their child, because the parent of that child is being accessed by transaction T1. So parent is file 2 and all its subsequent childs or children are getting intentionally locked. So this is what the concept of intention locking is, where if the parent has been locked by some transaction, intentionally all its children will be locked by the transaction, right? And if one of the child is being locked by the particular transaction, then the lock manager will only check whether any other transaction has got any type of locks on its parents or not. So this is what the concept of multiple granularity is. What is multiple granularity? It is a tree-like structure that is being used for data storage. So you can just go through this slide, and if you have any doubts, just tell me, because this is quite important in terms of 3 marks theory for your GTU. The concept remains the same. If the parent has been locked, then subsequently all its children will be intentionally locked. And if there is a request on any of the children to be logged, then it will only check whether it's any of the parents are being logged by some other transactions or not. That is what the concept of multiple granularity is. Just go through it, and if you have any doubts, just tell me. Yes. Anyone? Any doubts in multiple granularity? Anyone? Any doubts in this particular part? Okay, then let's move on to the next part of the concurrency control, that is lock manager or implementing lock. So how this locking mechanism is managed by the lock manager. You can see there is one chart. The black box are the locks that are being already acquired by the transactions. The white box are in waiting stage. So everything is being maintained in a lock table, right? So which transaction is already having which type of lock on which data item, which other transaction is also requesting for the same particular type of locks on the same data item. Everything is being listed on a page table, right? So the lock manager will come to know if one transaction releases the locks on some data item, then which transaction should be given that particular lock on the same data item. So this is what the mechanism of locking is, how the lock manager manages everything. Each and everything is managed by lock manager. A transaction will send the request to get the lock, will give the the lock manager will give the acknowledgement that yes, you can get the lock, and the performance of the operations of the transactions will be done by the transactions, and then it will be released. So everything is managed by the lock manager here. So that is what the concept of locking or lock manager is. The second one is, we already know that timestamp based concurrency control, or we can say timestamp based protocol. What it says, clearly says that there will be a given timestamp for a particular operation to be completed. If that operation is being done, that is okay. Otherwise, the next time slot will be given to the some other operation, right? So that is what timestamp based protocol means. Read operation will be given a particular timestamp, that yes, any transaction can read a data item between 2 a.m. to 10 p.m. 10 a.m. let us say, right? After that, from 10 a.m. to 2 a.m., right, there will be a write operation, a chance for all the transactions to write the data item. So likewise, all the timestamp based things will be managed by the transaction manager, right? So that is what timestamp based protocol is, and that is not that much important. So we are not discussing that much in deep. The next one is the main topic, that is deadlock. Now what is deadlock? Deadlock means one transaction waiting for second one waiting for third one, and third one is waiting for the first one. It should create a cycle. It should create a cycle. Otherwise, we cannot say it is a deadlock. Let us say one transaction waiting for second one and second one waiting for third one, right? Then we do not have any cycle. So this condition is not known as deadlock because it is not creating a cycle. It will be called as mutual exclusion. It will be known as mutual exclusion, right? So what is deadlock? A deadlock is a situation in which one transaction is waiting for the other transaction to release the resources. So let there be the set of three transactions. T1 holds waiting for T2, T2 is waiting for T3, and T3 is waiting for T1. So here we are getting one cycle. So that is why we call it as deadlock. And how we can say there is a deadlock? There are four conditions. Four conditions must get satisfied. Mutual exclusion, that means one process is waiting for some other process to release their resource. Hold and wait, that means one transaction is already having one resource and is also waiting for some other transactions resource. Non-preemption, that means no transaction or no process can forcefully ask the other transaction to release the resource. They have to wait, and there should be a circular wait. That means there should be one cycle. 1 to 2, 2 to 3, then 3 to 1. So this is what the main condition of deadlock is. So how to detect the deadlock? You can use wait for graph. You might have studied this wait for graph in your data structure subject. You can take the two examples. You can see here in the first example, A is waiting for B, A is also waiting for C. C is waiting for B and B is waiting for D. But here there is no cycle. You can clearly see that there is no actual cycle. There is one type of cycle on the A, B and C, but it is not complete cycle, right? There is no incoming edge towards A. So this is not the deadlock. But here you can see A is waiting for B and C, B is waiting for D, D is waiting for C and C is waiting for B. So you can see clearly there is a cycle between B, D and C. So you can say there is a deadlock among transactions B, D and C. So there should be a wait for graph where there should be some cycle in the particular transactions. Then and there we can say it is a deadlock. Now if there is a deadlock, how to recover it? We need to recover it by just identifying a victim. Now what is a victim? Victim means a transactions, if we just try to roll back, then it should incur minimum loss. That means a transaction with the minimum loss should be rolled back so that deadlock condition can be recovered. Right? So transaction which incurs minimum loss is rolled back and is known as victim. Now how to identify the victim? There are three possible ways. First way is we need to check which transaction contains the minimum number of locks. The second thing, after the minimum number of locks has been identified, we also need to see which transaction has executed the minimum amount of work, the minimum number of operations. And after that we can also check that which transaction is very far away from committing. That means which transaction is having the maximum number of operations left for execution. Which transaction is having maximum number of operations for execution, for completion, right? So this is how you can recover your database or deadlock, sorry. You can get a recovery from your deadlock. The next one is deadlock prevention. Now how to prevent a deadlock situation? So we have a wait die approach. Now what is wait die approach? We can say there will be one older transaction that has started quite earlier and there will be one younger transaction that has started recently. So if we can say if an older transaction is requesting a resource that has been already held by younger transaction, then older transaction will wait. It will not do anything, it will just wait for the younger transaction to release their resource. And if a younger transaction is waiting for the older transaction, right, then if the younger transaction wants the resource that is being held by the older transaction, then younger transaction will die. It is not allowed to wait. So there will be no deadlock situation because there is no waiting stage. There is no waiting period. So you can see this table. If older needs resource held by younger one, older one waits. If younger one needs resource held by older one, then younger one dies. It will revert back and roll back to its initial position. It will start again. The next one is wound wait approach. What is wound wait approach? If an older transaction is requesting a resource that is being held by the younger one, then it will forcefully get that resource from that younger one. It will not wait, it will not die, but it will make the younger one to die and get that resource from the younger one. So older one will get the resource from the younger one. And the second scenario is if a younger one is requesting a resource that is being held by the older one, then the younger one will be asked to wait. So it is the complete reciprocal of wait die. So older one needs the resource held by Y, then Y will be dying and the resource will be given to the older one. And if younger one needs the resource held by older one, then Y will be asked to wait. That is what the wound wait approach is. So there are mainly two types of deadlock prevention, wait die and wound wait. Other than that, we have one more, I can say, approach of deadlock prevention, that is timeout based approach. Each transaction will be given some amount of time. Let's say each transaction is being given 30 seconds. So if a transaction is able to complete all its operations and give commit command in that 30 seconds, that is okay. Otherwise, that transaction will be stopped and next 30 seconds will be given to the other transaction. It will be rolled back. The first transaction will be rolled back. Again, it has to start. So this is what timeout based approach means. This is what timeout based approach means. And this is the best possible way of deadlock prevention, because there won't be any deadlock, because we are giving a particular time slot for each transaction for their execution. So transaction T1 has been given 30 seconds. It is using data item A, B and C. Okay, after 30 seconds, if it is not able to release or it is not able to give the commit command, the complete transaction T1 will be rolled back. And all the resources A, B and C will be released, and from 31st second T2 will start its work. So there will be no deadlock situation in any case, right? So this is all about the transaction chapter. Any doubts, anyone? Then raise it. Any doubts so far in this particular chapter? Anyone? Then please raise it right now. If you have any doubts, just raise it. Yes or no? Any doubts, students? Anyone? Any doubts? Yes, students. Anyone? Any doubts? Yes or no? Okay. So regarding the Oracle certification, I have received only 61 responses. Still 9 students are remaining to upload their certificates on the Google form. So I request them, those who are remaining, please upload it by this Saturday. This is the last chance. I have given you 3 different deadlines, but this one is the last deadline now. If you are not able to upload it by this Saturday, then you are going to get 0 marks out of 15. And let me just talk about your EC1 class and what is the status of practical number 5. How many of you have uploaded practical number 5? Yes, that is also important. I can clearly see that still there are 10 students who are left to upload practical 5. So those who are remaining to upload this practical number 5, they are requested to upload it by this Saturday, because this practical 5 contains 5 marks. So 15 plus 5, that is equals to 20 marks of internal. So if you are not able to upload this practical 5 by this Saturday, then I will put 0. You can see here already 5 marks is displayed here. You can see Avesh, Bhavesh, Dharamjit, Harshik, Jeel, Karnavi, Meet, Mitul, Nishita and Shyam. These 10 students are left to upload practical 5 on Google Classroom. So all these students are requested to upload it by this Saturday. This is the last chance. Clear with this, guys? Both the instructions, Oracle certification and practical 5 lately by this Saturday. Jill, try to re-upload it if you uploaded, not uploaded then. If you are saying it is uploaded, try it, because it is clearly saying you have not uploaded, so you have to re-upload it. That is what I can give you. I can ask you to do. Clear with this? Clear with this, guys? All the instructions given to you. And most probably you will be having Viva, right? And you will know all the submissions, and your 30 marks of internal will be considered from your Viva. So make sure you prepare well. I think we have got all the materials over your e-content, or is there any PPT left on your e-content? Is there any material left on e-content of any particular chapter? Right, so you have all the materials, right? That's great. Good. So what next? Which unit you want to revise on the next week's session? Which unit you want to revise in the next week? Yes, students, which units you would like to revise in the next week? Anyone? Yes, anyone? PLSQL. So the SQL part or PLSQL part? Parthiv. Unit number 9, that is complete practical 1 to 5, or the cursors and the triggers and functions and stored procedures? Which one? Okay, unit number 10 you want to revise. Okay, then what we will do in the next lecture, that is on next Wednesday. Again, next Monday, Tejas sir is going to conduct the lecture of DS. Right, so on next Wednesday we are going to cover unit number 9 and unit number 10, both of them. Right, we will revise complete SQL, DDL, DML, DCL, TCL, all the joins, subqueries, and then the PLSQL also. So Parthiv, just remember that PLSQL doesn't have that much weightage in your exam. Only one question, hardly of 4 to 7 marks is asked. So don't bother about that particular chapter, right? Okay, so I hope I am clear with all the instructions regarding your assignments. And how many of you have not uploaded assignment 3? It is not compulsory, but it was given as a part of practice to you. I am going to see practical 5 and Oracle certification for your internal marks, and 30 marks will be put on by the Viva. The other faculty of other class is going to conduct Viva, and he or she will be putting the marks for it. Right? And you will be getting the Viva schedule very soon. When will be your Viva and all these things. So I think let's take the attendance. I am going to take physical attendance as I said. So you can just write it down in the chats, present yes or no. So Aditi, yes, Aditi, yes or no? Yeah. Alay, Amit, Anand, Ankit, Avesh, Bhavisha, Chintan, Darshit, Daksh, Dhairya, Dhruv, Dhyay, Dipen, Dirgha, Disha, Dusty, Harsh, Harshik, Harshjit, Hanil, Isha, Jai, Jeel, Jenny, Jwalant, Karnavi is absent, Keval, Keyur Desai, Keyur Dhokia, and I think Keyur Dhokia is absent, and Keyur Patel, yes, Kushal, yes, Khushi, yes, Kishan, Krunal, Kushal, Lisa, Mahima, Mon is absent, Meet, Amrutya, Rachadia, absent, Mihir, absent, Miloni, Mohit, Mitul, Naimish, Nandan, Nandini, Nirbhay, Nishita, Nishtha, Nupur, okay, Parth, Parthiv, Pujan, Rajesh, Ravi, Rutvi, Sanjana, Satish, Shilpi, Shreyash, Shyam, Suhasiniba, Vrinda, Yash, Yashpal Singh. Right, so I am just repeating the names of the absent ones. Shilpi, Satish, Ravi, Pujan, Nishtha. Okay, Nishtha is there. Just a moment. Mitul, Mihir, Meet Rachadia, Man, Keyur, Disha, Dharamjit Singh, Darshit Zaladi, Avesh and Bhavesh. These are the absent ones. Is there anyone left? Okay guys, then let's end this session. Thank you very much. We'll meet on the next Wednesday. Thank you very much guys. You can leave.